All right, our fraction recap today. So we've got our fraction right here. Just a quick reminder that we call the top number in a fraction the numerator, and the bottom number in the fraction is called the denominator. We'll use those words a lot as we are talking about those fractions, so it's a good thing to know what the numerator is, what the denominator is, and be able to use those frequently. So we're going to talk about first three different types of fractions that we see. We're going to start with this one right here. I would read this as 5/8. And here's what I want to notice about this. The numerator is the smaller number. The denominator is the bigger number. So when I have a small numerator and a big denominator, that means that I have what we call a proper fraction. Now, the thing is about proper fractions are always less than 1. So 5/8 is less than 1 whole. Again, proper fractions, small numerator, big denominator, they are less than 1. So then if I look at the next fraction, which is 9/4, this time I notice that my numerator is bigger and my denominator is smaller. So this time it's kind of flipped from a proper fraction. This is what we call an improper fraction. Now, improper fractions are always going to be fractions that are greater than 1. So that means there is one whole amount hiding somewhere in this improper fraction. And then our last type of fraction, we have a whole number, and then we have a smaller numerator and a bigger denominator. So when we see that whole number accompanied by a proper fraction, this is what we call a mixed number. And mixed numbers are always going to be greater than 1. Okay, so those are the three different types of fractions that we will look at. So we're going to look at first, how do we create equivalent fractions? So it's important to know that that word equivalent means equal. So we want to keep things fair as we change the look of our fraction, but we keep the value the same. So let's start with the fraction. I'm just going to make one up. Let's say 4/5. Okay, so when I create an equivalent fraction to 4/5, I'm keeping the value the same. I'm just changing the way that it looks. So one way that I can find equivalent fractions is I can build what's called a ratio table. And I skip count by the number on the top, and then I skip count by the number on the bottom to build those equivalent fractions. So if I start with the top, if I'm skip counting by 4s, I have 4, 8, 12, 16, 20. If I skip count by the 5 on the bottom, that'd be 5, 10, 15, 20, 25. So what we've done is we've built 4 equivalent fractions to 4/5. So 8/10 is equivalent to 4/5. 8/10 is even equivalent to 16/20. Okay, if I do another one like 9/10, so again, skip count on the top, so that'd be 9, 18, 27, 36, 45, and then I skip count on the bottom by 10, so 10, 20, 30, 40, 50. Again, we're just building those equivalent fractions. But sometimes we might have to solve kind of equivalent fraction puzzles, things that look like this. So I know that 5/8 is going to be equivalent to something that has a denominator of 48, but I don't know what the numerator is. So I have to figure out what the numerator is. So, excuse me. So what I'm looking for is something called a scale factor, okay? It's a number that I either multiply or divide by to go from one number to another. So I always want to make sure my arrow, my scale factor, points to what I am missing. So I see right now that I am missing my numerator, but I see a relationship. I see a scale factor from the number 8 to 48. And so what I do to 8 to get 48 is I do 8 times 6. So my scale factor is times 6. Now here's the deal. We want to keep things fair and equal. So whatever I do to the bottom, so whatever I do to the denominator, I also have to do the same to the numerator, to the top. So I also have to do 5 times 6, which would give me 30. So 30/48 is equivalent to 5/8. Okay, let's look at this next one. So this time, I don't know what the numerator is that belongs to the denominator of 3, but I know that whatever it is, it has to be equivalent to 22/33. So again, I'm looking for that relationship. I'm looking for that scale factor. And I see it between 3 and 33. So what I do to 33 to get 3 is I divide by 11. So my scale factor is divide by 11. Again, whatever I do to the bottom, I have to do to the top. So 22 divided by 11 would be 2. So 2/3 is equivalent to 22/33. Okay, let's keep going here. Okay, I see that this time I'm missing the denominator. So I see a relationship between 6 and 30. Oops, I messed up. Remember, my arrow's got to point to things that I'm missing. And I'm missing the denominator on this side. So 30 divided by 5 would give me 6. And whatever I do to the top, I have to do to the bottom. So 50 divided by 5 would give me 10. Last one down here, I see a relationship between 12 and 72. That would be 12 times 6 gives me 72. So what I do to the bottom, I have to do to the top. So 9 times 6 gives me 54. Okay, again, that's just building equivalent fractions. Two different ways to do it. We can build a ratio table, or we can look for those scale factors. And then we can also simplify fractions. So when I simplify fractions, I'm trying to put it in its simplest form. I'm trying to get the smallest fraction possible while again keeping the value the same. So what I'm looking for here is a number that my numerator and my denominator are both divisible by. So I see that 8 and 10 are both even numbers. I can divide top and bottom by 2. And when I do that, 8 divided by 2 gives me 4. 10 divided by 2 gives me 5. Now, 4 and 5 aren't divisible by the same number. 5 is a prime number, so I can't make that any smaller. So 8/10 simplified is the fraction 4/5. Okay, let's do 15 over 60 or 15/60. One ends in a 5, one's in a 0, so they both are divisible by 5. So I have 15 divided by 5 gives me 3. 60 divided by 5 gives me 12. So right now I have 3/12, but I think that 3 and 12 can both be divided by the number 3. So 3 divided by 3 gives me 1. 12 divided by 3 gives me 4. So 1/4 is the simplified fraction of 15/60. So sometimes you might have to divide multiple times to get that as small as we can go. Let's move on to 54 and 54 over 63. They're both divisible by 9. 54 divided by 9 gives me 6. 63 divided by 9 gives me 7. 6/7 is as simple as I can get. Okay. 16 over 32. I see that they both have 8 in common. So 16 divided by 8 gives me 2. 32 divided by 8 gives me 4. Oh, and look at that. 2 over 4, they're both divisible by 2. So 2 divided by 2 gives me 1. 4 divided by 2 gives me 2. So 1/2 is the simplified fraction of 16/32. Now I have 21 over 77. I know that they're both divisible by 7. So 21 divided by 7 would give me 3. 77 divided by 7 would give me 11. So these are both prime numbers here. They're as small and as simple as I can get. Last but not least, 4 and 64. They are both divisible by 4. So 4 divided by 4 would give me 1. 64 divided by 4 would give me 16. 1 over 16 is as simple as I can get it.